Good morning, everyone, and welcome to this lecture. We are dealing with collisions. We are dealing with head-on collisions. And in the previous class, we had discussed a question. Do we remember this question? Yes or no?
Yes, sir.
We had discussed this question. What will happen with what velocity or what kinetic energy the block will move, right? Now I can make a question. Remember, we are only trying to do those questions which are more likely to come in the exam. Remember, I can make almost infinite number of questions on collisions. We cannot keep on solving questions on collision. We're only going to concentrate on what type of questions are coming in the exam these days and more likely to come. Do we understand this?
Yes, sir.
Remember, I can teach you collision and rotation for 2 years complete, but still I will have questions left. So I can take that much of classes on that. So we must understand that we should restrain ourselves to the boundary of questions that can come. Okay. And these are the questions that are coming. So can we have this one? A ball moving horizontally with a speed v strikes a bob of simple pendulum at rest. The mass of the bob is equal to that of the ball. If the collision is elastic, then the bob will rise to what height? I'll give you a minute to do it. Yes, do we have any answer?
1 minute, sir.
No one? Nah? No one knows the answer. No one knows the answer.
V square by 2G, sir.
V square by 2G. That is correct. Why did it take you so long to get the answer? Why did it take you so long to get the answer? This is exactly the same problem as this one. The problem is just put in reverse. Here the bob is coming from a height and striking the block. This problem is reverse. Block is coming and striking the ball. What difference does it make? It is the same question. Do we understand this?
Yes, sir.
What, sir? If you understand this, you should have done this. Okay. Try and understand. Questions are going to come on the same class. Let us see if you can do this one. Remember, the more the number of questions that you do. What about that sheet? Are you doing that sheet or not? Huh? You get that sheet?
Yes, sir, we got it.
I hope you are doing it. Today, probably we will be done with your collision. So your sheet up till collision should be done. You got the sheet for rotation as well, yes or no?
Yes, sir.
So once I start rotation, you must start with rotation. The sheet is specifically made for you, for everyone. Everything is given under small topics. Do you see that?
Yes, sir.
This. For rotation, it will be again divided into 10 or 15 topics, small topics, angular momentum, this, that. So as soon as we finish one, you do that section. Do we understand this?
Yes, sir. Okay, sir.
Apart from the question that I am doing, if you do those questions, you are good enough to solve any problem. Let us see if you can do this one. Question number 2, I'll call it for today. A particle of mass m moving with a horizontal speed of 6 meters per second. If m is very small compared to capital M for one-dimensional elastic collision, the speed of the lighter particle after collision would be. It's not given the heavier particle. The heavier particle is moving with a speed of 4 meters per second. It's not given there. The heavier particle is moving with the speed of, the heavier thing is moving with the speed of 4 meters per second. Yes, I'll give you 2 minutes to solve this. No one with an answer.
A, sir.
One more thing you must remember, both are moving in the same direction.
A, sir.
A, 2 meter per second in the original direction. Are you asking each other? Someone got the right answer, that let us say, or are you all doing it?
We are doing, sir.
The answer is A, 2 meter per second in the original direction. How
Yes,
did
sir.
you get it? Remember I told you that case where one
A
body is very heavy and yes,
Yes,
we
sir.
just need to apply this. So everyone got this or shall I solve it? So you just have to put V.
No, sir, we got it.
Okay, if I don't have to write anything, that means we are doing something correct. Okay,
Yes, sir.
well done. Good. More the question you solve, the more is the probability that same question you will see in the examination hall. Now, before going any further, let me give you one more thing that you can apply straight away. So let us write that thing so that you don't have to calculate it every time you face a question. That is the loss of kinetic energy. Loss of kinetic energy in a head-on collision. Remember, 99% of cases that you will encounter in your exam will be of head-on collision. Oblique collision, there will be some problems that I will tell you, and you don't have to go into much detail. There will be something that you will have to remember. It's something that you can find out. So we will solve very limited number of questions over there. These are the types of problem head-on collision which are more likely to come. Oblique collision, a very difficult problem, will only come when JEE Advanced becomes very difficult, which is highly improbable. Anyways, what is the loss of kinetic energy in a head-on collision? Now, how do you find this loss of kinetic energy? The original formula is very simple. What will be the original formula? It will be KE final kinetic energy of all the particles, minus KE initial. Do we understand this?
Yes, sir.
And if it is an elastic collision, that will be 0. If it is an inelastic collision, this would be negative because final kinetic energy will always be less than initial kinetic energy. Now, there is one case which is known as, should I say, super elastic collision, where the kinetic energy of the final bodies, the sum of kinetic energies can be uh, more than the initial kinetic energy. In that case, what happens is there are some internal energies of the bodies which get released. That only happens when we are bombarding a nucleus with other particles. So the energy inside the nucleus may get released. That is in nuclear physics. We don't have to worry about that. Right now, this change in kinetic energy can be found out from this formula. So in any case, if you have to find out what is the loss in kinetic energy, you can obviously use formula number 1, find out the total final kinetic energy, find out the total initial kinetic energy, subtract the two, and you will end up with this problem, with this concept. But
Yes.
we can obviously design putting the values of everything in terms of M1, M2, and all that. We can devise a formula which can be applied everywhere only for head-on collision. So that is the formula that I have got for you. Minus sorry, this should be equal to minus mu by 2 u relative square into 1 minus e square. This is the best way in which I can put this formula. Now there are certain terms that are coming here. The first of this term is mu. Anyone heard about this term mu? We'll come across this term in a chapter known as simple harmonic motion. This mu is known as reduced mass. It also comes sometimes in center of mass. I skipped that part. It doesn't normally come in an examination hall. This mu is known as a reduced mass.
Reduced mass.
Reduced mass of a system of two particles. Whenever this question comes, it would basically be a question of two particles. Remember, this formula is only valid for two particles, collision of two particles. If there are more than
Yes.
two particles, this formula cannot be applied because we cannot find out the reduced mass. Okay, so it is a very simple case. This formula is only applicable for a collision of two particles. Remember that. Not more than two, because if it is more than two, this formula does not apply. Then you have to go to the original formula.
Yes,
Reduced
sir.
mass mu can be written as m1 m2 upon m1 plus m2. This u relative is the relative velocity, so you can write it magnitude wise, u1 minus u2, or you can write it u2 minus u1. If they are moving in the same direction, they will get subtracted. If they are moving in the opposite direction, it will get
And
added up. Do we understand this? So every formula that I am giving you has to be applied with proper vector or sign convention. This formula is only valid for
two particles.
two particles. Remember that.
Yes, sir.
E is your coefficient of restitution. So if it is a perfectly elastic collision, the value of E is 0. The value of E is
Is one.
1. You applied in that formula, the change in kinetic energy is 0. If
Yes,
it
sir.
is 0, it is a perfectly inelastic collision. The body will get embedded, and then you will get the answer as minus. Why minus is coming? Because final energy is less. Minus mu by 2 into u relative square. Do you understand this?
Yes, sir. Yes, sir.
So if ever you encounter, and that is the case that you should encounter in your exam, should be collision between two particles, most likely a perfectly inelastic one or a perfectly elastic one. This is the formula that you can apply here. Let us see if you can do this one. This is the question that has come in many exams, many times. JEE Main, NEET, CPMT, you name them, and you have it. So this is the problem. A body of mass m moving with velocity v makes a head-on collision with another body of mass 2m, which is initially at rest. The loss of kinetic energy of the colliding body. Basically, the question should be framed in a different way. Find the loss of kinetic energy. When they ask the loss of kinetic energy of the colliding body, it actually means I'll give you 2 minutes to do this. Well, it is not given what type of collision is this, right?
Yes, sir.
Take right, so we can't solve it. So we have to, it's not given what type of collision is this. So then we will solve it in a different way. Then we will solve it in the way that it is there. We will take it as a perfectly elastic collision.
Elastic. Okay, sir.
Perfectly elastic collision, we have to take it. And then remember, we have to solve it in the way the question is the loss of kinetic energy of the colliding body. So you have to find out. You have to find out the initial kinetic energy of the body. You have to find out the final kinetic energy of the colliding body, and then find the difference. So you cannot apply that formula that I have given you. That formula is a total loss in kinetic energy. Do you understand this?
Yes, sir.
Okay. Yes, so we got any answer?
C, sir.
C, 8/9. Everyone got this? How to do this?
Yes, sir.
You can just find out the final velocity of ball 1 or ball 2, whatever you call it. Find the initial velocity, find the final velocity, find the change, and you are done. Everyone understands this?
Yes, sir.
Good. You are doing good in collision. Good. Remember, the more the number of problems, the better we are. And I'll give you all the problems that I think are possible to come in the exam.
Yes, sir.
Comes this one. Question number 4 or 5, whatever the number is. Two particles of mass m and 2m are moving in opposite direction on a frictionless surface, collide elastically with velocity v and 2v respectively. Find their velocities after collision. Also find the fraction of kinetic energy lost by the colliding particles. Will they lose any energy?
Sir.
You can do the second part first. Also find the fraction of kinetic energy lost by the colliding particles. Will they lose any kinetic energy? Will there be any net loss of kinetic energy in this collision? Kinetic energy final and kinetic energy initial of the individual bodies? Yes, there may be, but what about the total system in combination? Will there be any loss of kinetic energy?
No, sir.
No. Why no, sir?
Because in elastic collision, kinetic energy before collision is equal to the after collision.
Remember, total kinetic energy before collision is equal to total kinetic energy after. The individual kinetic energies can change. Do we understand this?
Yes, sir.
Okay, so here's the question. Yes, do we have the answers?
1 minute, so 1 minute. So we are doing.
Yes.
ఏమొచ్చినాయి?
Is it such a difficult question? No. The first thing is I will find the velocity of center of mass of the system. What is the velocity of center of mass? The question is put in such a way. The question is put in such a way that the velocity of center of mass is 0. Yes or no?
Yes, sir.
I call this as body 1. I call this as body 2. What will be the velocity of body 1? 1 plus E times VCOM minus E times U1. This term is 0. So the answer is minus 2V.
Minus 2V.
That's it. V2 will be 1 plus E times VCOM.
Minus EU2.
Should not have taken so much of time, dear.
Minus V.
No. U2 is...
No, sir. VV.
That's it.
Sir, the question is wrong, sir. In the question they have given mass m has velocity v and mass 2m has velocity 2v.
Oh, yes. I did not read
So
it.
I got minus 5/3 v and v/3.
You are absolutely wrong. I did not read the question properly. My mistake. But I just look at the diagram. So from the diagram, I solved it actually. I did not look at the question. You are correct. So I should change this question. M moves with a velocity 2v and 2m moves with a velocity v. Normally, this is how the question would be framed because they want the velocity of center of mass to come 0. So they will have the opposite thing. M will have 2v and 2m will have v. That is how they frame it so that the calculations are simple. See, so simple calculation.
Yes, sir.
Okay, but you are
Yes.
right. The question was written wrongly. I agree on to it perfectly. Chalo, shall I give you the next one?
Yes, sir.
This is the next one. On a frictionless surface, a ball of mass m moving with a velocity v makes a head-on collision with an identical ball, same mass, at rest. The kinetic energy of the ball, so this is the combined kinetic energy they are talking about. The kinetic energies of the ball after the collision is 3/4 of the original. Find the coefficient of restitution. I'll give you 2 minutes to solve this. Let me know once you are done, bacha. Do you have any answers?
Zero point 732, sir.
0.732. I love fractions. To give me the answer in fraction, the answer is 1 by root 2. Are you getting it?
Root 2. 1 by root 2.
The answer is 1 by root 2. Are you getting it? Okay, I'll wait for a minute. It seems like you are not on the right track. So let me intervene here. Both the balls are having the same mass m. The first step is I find out the reduced mass. When both are of the same mass, the reduced mass is going to come as m by 2. Yes or no?
Okay. Yes, sir.
If the initial kinetic energy is k, then the final kinetic energy is 3/4 of the original. Yes or no?
Yes, sir.
So what is the change in kinetic energy? Minus 1 by 4
Yeah.
times of k. Yes or no?
Yes, sir.
And this k is nothing but only one ball was moving. Minus 1 by 4 mv square by 2. Yes or no?
Yes, sir. We got this.
That should be equal to that formula minus mu by 2 u relative square 1 minus e square.
Yes, sir.
2 say 2 goes away. Minus say minus goes away. So what are we left with? mv square
M
by
by
4
4
is equal to mu, which is m by 2.
M by 2.
U relative is v minus 0. So it is v square 1 minus e square. Are you getting my point?
Yes, sir.
That's it. You get your answer. I hope you can do it from here.
Yes, sir.
So the value of E will come as 1 by root 2. See? So simply we got this. Do we understand this, or this has gone above our head saying bye-bye?
అర్థమైంది కాదు మనకు ముందే వచ్చిందని మనలే.
Charlie, move ahead in life.
Yes, sir.
So there could be questions where instead of asking you the velocities after collision, they could ask you the coefficient of restitution.
Okay,
Here is
sir.
one of a block of mass m is moving with a velocity v, collides with another block of mass 2m at rest. The lighter block comes to rest after collision. Find the coefficient of restitution. Read the question. You'll know everything. Only one thing is unknown. It could be E, it could be V1, it could be V2, it could be U1, it could be U2. Shall I do it?
No, sir, we are doing.
I've only told you one formula, that's it. Just have to apply it. I'll also do it by the same formula. I'm not like a book that they give you one formula and solve the question in a different way. If I give you something, I'll solve everything from that thing. So that you get the confidence that this thing will work. Shall I do it?
Root 5/8, sir.
Half is the answer that I have. It is nowhere close to root 5/8. Yeah, it is closer to 4/8. Chalo, I'll give you 1 more minute to think about it. Okay, so my time has come, or you are still trying it? I will call this block as block 1 and I will call this block as block 2. Block 1 has a mass m, velocity v. Block 2 has a mass 2m, it has rest. The lighter block comes to rest. So what are things that I know? This is the value of u1. This is the value of u2. And this is the value of v1. That's it. I find the velocity of center of mass of the system. It is m into v divided by m plus 2m. The other block is at rest. So it is v by 3. Then I put the formula for v1. v1 is 1 plus e times vcom v by 3 minus e times u1. u1 is v. And this v1 is nothing but equal to 0. I think you can solve this simple equation and get me the value of v. Get me the value of e.
Yes, sir.
And the value of e that you will get from here, my dear friends, is simply equal to half. I could calculate this in my head. Was it so difficult?
No, sir.
What were you doing then? Have you noted this down?
Yes, sir. Done.
Do this one fast. Block of mass 2 kg is pushed towards a very heavy object moving with a velocity 2 meters per second closer to the block as shown. Assuming elastic collision, find the velocities of the two blocks. I hope you can do this one. Huh? Find it
Sure.
out or not?
Finding, sir.
Okay. Give you 2 minutes. Yes, do we have any answers? Huh? No one has any answers. Everyone is looking here and
We
there.
got it, sir.
Yes, so what is the answer? Tell me.
Say,
Sir, I have taken 10 meter per second in the positive direction. And my
Okay.
velocity, sir, minus 12 meter per second and minus 2 meter per second.
First one is wrong. First one is wrong. The second one is obviously right.
sir, V1 is 2 meter per second, V2 is minus 6 meter per second.
That is also wrong. Everyone has got velocity of this one correct. But everyone has also got velocity of this one wrong. I'll give you 1 more minute to do it again.
So V1 is minus 10. Sorry, V2 is minus.
Hey Bhagwan. Still have time?
Minus 14, sir.
Minus 14. After 5 attempts, you have got the correct answer. Very sad. After 5 attempts, you have got the correct answer. The correct answer is minus 14. Velocity of center of mass here is the velocity of the heavier ball. It is minus 2,
Yes, sir.
not plus 2. Velocity of heavy object will remain same. You just have to find out the velocity of the lighter one. V1, 1 plus E is 1 multiplied by minus 2 minus 1 times 10, and the answer is minus 14. Please do not
Yes,
make this
sir.
mistake. It's not accepted, this mistake. I hope we have understood this.
Yes, sir.
Okay, you understood it last time also. Okay, I hope better sense will prevail in this question. Eh? So this is the question. And it has 2 parts. It actually had 4 parts, but we'll just do the 2 one. Okay, so here it comes. Let's see who can do this. Oops, where is this thing? Ah. 2 balls of mass 2 kg and 4 kg are moved towards each other with velocity 4 meter per second and 2 meters respectively. They are moving towards each other. On a frictionless surface. After colliding, the 2 kg ball returns back with the velocity of 2 meter per second. Find these 2 things. Let's see who gets this one. Anyone with anything that looks like an answer? Eh?
1 minute. మళ్ళీ చెప్పాలి మళ్ళీ చెప్పాలి ప్లీజ్ వన్ లైక్ ఇంకా 1 E is 1/2 sir, V2 is 1, velocity of 4 kg body 1.
That is correct. E is half and velocity of the first body. The first body I will call this one. This is body number 1. This is body number 2. And this body number 1 is moving like this. Body number 2 is moving like this. The first thing that I have to find out is the velocity of center of mass. And remember, the question would be framed in such a way that the velocity of center of mass is going to come as what?
0 sir.
Now you know the velocity of the first ball. The velocity of first ball is 2 meters per second, so it is -2. You understand? It was going like this, that is positive. This I have taken as positive. It comes back, it is -2. That should be equal to 1 plus E times VCOM is 0 minus E times U2. U2 is 4. So that gives me the value of E as half. Once I get the value of E as half, I can write it from here. 1 plus E times 0 minus E is half times the velocity. The velocity was -2, so it becomes +1.
Yes sir,
Do you understand this?
we got it sir.
Thank God. We got this.
Yes sir.
Then we move ahead and we will just write one note. You can take it as a question. You can take it as a note. Body falling from a height. Now what happens? You must have seen this in your day-to-day life. You must have seen this in your day-to-day life. A ball will fall from height h. Then it rebounds and obviously does not reach the same height. After rebounding, it reaches some height h1. After the first rebound, it reaches height h1. Then it might rebound back again. And after the second rebound, it reaches height h2. And after the third rebound, the height increases. Yes or no?
Yes sir.
The coefficient of restitution normally is given as E. E is given as the coefficient of restitution. Now, what they can ask you is what is the height it attains after first rebound, second rebound, third rebound, or so on. They can also ask you with what velocity does it rebound back. So once it hits the ground, it will rebound back with a velocity v1 here. Do we understand this?
Yes sir.
Similarly, it will rebound back, use the wrong color, with a velocity v2 here, right? So h1, h2, h3, if I call this h1, h2 up till hn are the heights that it reach after rebounding first, second, twice. v1, v2 up till vn are the velocities with which it rebound. Now we can easily prove it, and we are not going to see it. The height h1, or I can say hn, can be given by this formula, e raised to the power of 2n times h. Do we understand this?
Yes sir.
So after the first rebound, the velocity, the height it will reach will be e square into h. After the second, e raised to the power 4h, e raised to the power 6h, 8h, and do we understand this?
Yes, sir.
Similarly, I can write the formula for the rebounding velocity Vn is e raised to the power n times v, where this v is the velocity of first falling down, and this v velocity is nothing but it is equal to root of 2gh. Do we understand this? So I can write this
Yeah.
velocity after the nth rebound will be e raised to the power n root of 2gh. Just need
Yes,
to
sir.
keep this in mind. Do we understand this?
Yes, sir.
Okay, so note this down. I'll give you a minute to note it down.
Done, sir.
This is the question. A ball of mass 2 kg is dropped from a height of capital H above a horizontal surface. It rebounds to height h after one collision, one bounce. The graph that relates capital H to h is shown in the figure. The ball was dropped from an initial height of 81 meters and made 10 bounces. The kinetic energy of the ball immediately after the second impact is how much? Let's see if you can get me this answer. Yes, bacha. No one with an answer. Huh?
No, sir.
See, when the question is, when the language of the question is changed, we all fall flat. Oops, what has happened here? Not something good. Okay. So, from this graph, this h is the height from which it is dropped, and this small h is the height after which it rebounds. After the first rebound, yes or no?
Yes, sir.
So this h must be equal to e raised to the power of 2 into n. N is how much?
1, sir.
Into h. Put the value of h as 40 is equal to e square into 90. From here, you will get the value of e as 2 by 3. Yes or no?
Yes, sir.
That's it. That's all the question, my dear friends. You've got the value of E. What you need to calculate now is the kinetic energy after the second impact. So after the second impact, you can find out the velocity after the second impact. What will be the velocity after second impact? E raised to the power of
2. Sorry.
2
2. Yes, sir.
into root of
Root of 2.
2gh. Yes or no?
Yes, sir.
So V2 will become 4 by 9 into root of 2 into 10 into 81. Yes or no?
81. Yes, sir.
But you don't have to find this. You have to find the kinetic energy. So what is the kinetic energy, my dear friends? Half m into V2 square. Just put the values. Half into m is 2 into V2 ka square, 16 by 81. That is why 81 was given. Into 2 into 10 into 81. Why was it such a difficult question? That is your answer, my dear friends. Did we understand this, or this has gone about it saying bye bye, bye bye, bye bye, bye bye, I'm going?
Sir, we got it.
Okay. Have you noted it down?
Done, sir.
If you noted it down, then I will give you this small diagram, and this is a small note. So I mean, this diagram is drawn in a different way, but try to understand what this diagram tries to illustrate. I am dropping the ball from an initial height of h naught. Everyone can see this.
Yes, sir.
And it falls down with a velocity of v naught. Do we see this? V naught is root over 2gh. Yes or no?
Yes, sir.
After first rebound, it will bounce to a height h1. After second bounce, h2 and so on. Yes or no? We have found
Yes,
out the
sir.
value of h1, h2, v1, v2. The next thing that they can ask, if the paper becomes very difficult, is what is the total distance traveled?
Okay.
What is the total distance traveled by the ball? Now, if I just give you the total distance traveled by the ball, let me call this as, because it is moving along y. So this total distance traveled by the ball will be equal to h naught plus 2 times h1. Yes or no? You
Yes.
do h1, then it will come down h1 plus 2 times h2 up till this will continue till infinity because this is an infinite geometrical series. Yes or no?
Yes, sir.
Similarly, if they ask you the total time it takes, tung 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 tung, so it will be equal to the first time t naught to fall plus 2 times t1 plus 2 times t2 up till infinity. That we understand this.
Yes, sir.
You can formulate a formula for this. The total distance it travels, and just write this. The total distance it travels when we find out the sum of this infinite series, it will come like this. H naught into 1 plus e square divided by 1 minus e square. Remember this result.
Yes, sir.
Total time T. See, you will not be able to calculate it in the examination hall. So remember it, 2h0 by G. This is your initial time to fall. And this has to be multiplied by 1 plus E upon 1 minus E. If you understand the similarity between the two formulae, you should be able to remember them when time comes. So we understand this?
Yes, sir.
Okay, so this was all about a 1D collision that you ever have to remember. Now let us quickly move on to 2D collisions or oblique collisions, and we'll not go into much detail. We'll just write some points. How are you going to solve that question? Some small points, and then we are done. Okay?
Yes, sir.
Because if the question in this 2D and 2D collision is very tough, you will not have sufficient time to solve it in the examination hall. So you can only solve it when it is very simple, and that is the way it should be. It should be coming if it ever comes. So we'll now move on to oblique collisions. Everyone has noted this formula down?
1 minute, sir.
I'll give you 1 minute.
చిన్నగా అది ఎక్సేనా టీయా ఎక్సా మరి టీ కదా క్యాపిటల్ టీ కదా ఎక్సా అది ఎప్పటికి ఏమైంది
Done, sir.
Everyone done?
Yes, sir.
So we'll move quickly on to oblique collisions. Now what will happen in oblique collisions is that it will not be head on, it will be collision in 2 dimension. Do we understand this?
ఎస్ సార్
Okay, now in general, how you are going to solve those questions, I will give you just a thing. We can use those things and we can solve problems. Now most of the questions which are going to come in your 2D or oblique collision, they would be normally perfectly elastic collision, because if they are not, then the problem just becomes a bit more illustrative, and you don't have the time to solve it in the examination also. We'll just try to write some points, and that we can use. These points can come as questions in your they might ask you some theoretical question based on these points. So just remember. So it is going to be an oblique collision. So the first thing you must remember is to identify the line of impact. Do we understand this?
Yes, sir.
Identify LOI. LOI means the line of impact.
Fact.
Now remember, impulsive forces act along
Along line of impact.
along the line of
Line of
impact.
impact.
Okay, you can apply the value of E along the line of impact. So it is only along the line of impact. We can write it as V2 minus V1 divided by u1 minus u2. All these velocities are along the line of impact. Do we understand this?
Yes, sir.
Then
Fourth.
you can apply law of conservation of momentum along the line of impact. That would be one axis, and this line of impact is normally your common normal, yes or no? So if it is your common normal, you can apply it along common normal and along CT. So basically, you can apply this law of conservation of linear momentum along two axes. The two axes must be perpendicular. Do we understand this?
Yes, sir.
So if one axis is your line of impact, the other axis would be your line axis which is perpendicular to it. Normally it will be common tangent. Okay.
Yes, sir.
LOCM can also be applied along, in most of the cases you can do that along x-axis and y-axis separately. Do we understand this? So either you do this step or you do this step. Okay. Do we understand this?
Yes, sir.
Then momentum of individual particles don't change. Now, if you can identify which is your line of impact, the momentum of individual particles don't change along common tangent, which is perpendicular to the line of impact. Do we understand this? Because your forces are going to act only along the line of impact. So if we take a direction which is perpendicular to the line of impact, your momentum of individual bodies also will not change. Do we understand this? These are some of the points that you must remember while solving any problem. Do we understand this? Do we understand this? Have we noted it down, beta? Okay. Now remember one more point, and that is actually a question, but we will take it as a point, because if a question comes, you can just instead of solving it, you can just write it as a point and remember it. So see, there is no point of solving difficult questions which are not going to come, questions which even if you have solved and gone, if they change the values, you will take a lot of time to solve it. So remember this also as a point. And what is the point here that we are going to show? If two balls of same masses, so you can see one ball, oops, wrong color. You can see one ball of mass m, it makes an elastic collision. So the collision is elastic. And another ball identical means they have the same masses. Do we understand this? And the other ball is at rest. So there are three things that has happened here. In fact, four things. And the collision is oblique. Four things that happened here. Number one, both the balls have the same mass. Number two, one of the balls is at rest. Number three, collision is elastic. Number four, collision is oblique. If it is not an oblique collision, what will happen? This ball which is moving will stop and the ball which is at rest will move. Yes or no? Perfectly elastic collision, two identical balls, that is what they happen. You know, they interchange their velocity. Yes or no? But if the collision is oblique, so what has changed here? Instead of a direct collision between a ball which is at rest and the ball which is moving, it's an oblique collision between a ball which is at rest, billiard ball, pool ball, your cue ball moves and your other balls are at rest. Both are of identical masses. One is at rest. And if you have not a head-on collision but an oblique collision, then what happens? Both the ball will move at right angles after the collision. Both the balls will move at right angles after the collision. Very important point, because I have seen questions come on this. This is a diagram, and this is a diagram of a billiard ball. This is a diagram of a billiard ball, and you can just write this diagram, draw this diagram to understand the thing. We don't have to solve it, you just write it. So as you can see, my dear friends, this is your billiard ball, and this is the ball which is at rest. It's an oblique collision, moves with a velocity v. After collision, what happens? Ball number 1, the green ball, moves with a velocity v naught sine theta. Ball number 2, which is the pink ball, moves with a velocity v cos theta at an angle of 90 degrees. This is after the collision. They have written before collision. Before collision, they were at rest. So this. This is before collision. Do we understand this? And this is after collision. Do we see this, bacha? Yes or no? No or yes? Note this down. Have we done this, bacha? Yes or no? No or yes? Okay. Now just to illustrate a question, we are just doing it for the sake of doing it. This question may not come, but let me do a different one, which is more. Do this one probably. Chalo, this is the question that we'll start proceeding with. Let's see if you can do this. A ball moving with a velocity of 9 meters per second collides with another stationary ball. After the collision, both the balls move in a direction of 30 degrees with the initial direction. After the collision, their speed would be. Let's see if you can solve it. You have 2 minutes to do this. Yes, anyone with an answer? Do you want a hint?
We are doing, sir.
You want a hint or not? No. Anyways, if you draw a diagram, question looks like this. Do it fast. Take your time. We're only going to do a couple. Shall I help you out? Yes, sir. No, sir.
We are doing, sir. 1 minute, sir.
Okay, okay. Take your time. Take your time.
Sir, it's B, sir, 5.2 meter per second.
That is B, sir, 5.2 meter per second. And you can see from my smile that is the correct answer. That is correct. Good. So what do you need to do if you understand this thing? First, you can see what is the initial momentum. Initial momentum is along x-axis, that is 9 into m. Yes or no?
Yes, sir.
Along this direction. It's only the momentum along x-axis. There is no momentum along y-axis. Now, if you have to see along x-axis, what is the momentum? The momentum of this ball. If I call the velocity as v1, and if I call the velocity as v2, the momentum will be m into v1 plus m into v2
V2, yes, sir.
multiplied by cos of 30. Yes or no?
Yes, sir.
Because I have to take the component of momentum. Yes or no? Here I've
Yes,
assumed
sir.
that v1 and v2 are both different, but are they different? If I apply this momentum conservation along this will be m v2 sine 30. Yes or no?
Yes, sir.
This will be m v2 sine 30. Sorry, m v1 sine 30. Yes or no?
Yes, sir.
Now, there was no initial momentum along y-axis, so there should not be any momentum along y-axis after collision as well. So this thing and this thing must equate. Yes or no?
Yes, sir.
Everything is same. That means v1 and v2 both are same. Yes or no?
Yes, sir. V1 is equal.
You can just take this as a note that if they are moving at the same angle with the same mass, their net momentum along y-axis will cancel each other out. Yes or no? So they will have same velocity. So you just have to apply this equation. Along x-axis, from y-axis, we have got v1 and v2 both are equal. So I can just write 9m will be equal to m into v1 plus v2 becomes 2v. Yes or no? Cos 30 is root 3 by 2. Do we understand this?
Yes, sir. Yes, sir.
M and m cancel. 2 and 2 cancel. Your v becomes 9 by root 3. 9 can be written as
3 square.
3 squares. 3 into root 3 into root 3. So the answer will be 3 times root 3. Yes or no?
Yes, sir.
Root 3 is 1.7 multiplied by 3, 5 point something. And the only option with 5 point something is option B. Do we understand how we are supposed to do this?
Yes, sir.
Everyone, can I have some raise hands from everyone that we got this? Okay, can you move on to the next question?
Yes, sir.
This is the next question. A ball of mass 1 kg moving with a velocity of 0.4 meter per second collides with another stationary ball. After the collision, the first ball moves with a velocity 3 meter per second in a direction, making an angle of 90 degree with its initial direction. What is the momentum of the second ball after collision? Remember, they are not given his mass. They are not asking his velocity. They are only asking his momentum. I hope you can do this.
ఏంటి 0.2? Sir, it's 0.5.
Sir is 0.5 or answer is 0.5?
Answer is 0.5.
Answer is 0.5. That is correct. Everyone got this?
Yes, sir.
So how are we supposed to do this? It is pretty damn simple. From where I see, you just need to draw a correct diagram. Once you understand the correct diagram, everything will come automatically after that diagram. So this is the diagram that I am using. Yes or no? Initial momentum was only in the x-axis, right? Initial momentum along x-axis is 1 multiplied by 0.4. Yes or no?
Yes, sir.
If I call the final momentum of this body as p, that must be equal to p cos theta. Yes or no?
Yes, sir.
Then if I call the vertical momentum, it will be p sine theta here. This p sine theta must be equal to 0.3 into 1. Yes or no?
Yes,
So you
sir.
know the value of p cos theta, you know the value of p sine theta, you should be able to find out the value of p. Yes or no? No or yes?
Yes, sir.
Give you one more question, do it fast. There will be questions given in your sheet on this. Do you have the sheet? Can you check whether there are questions on this or not?
1 minute, sir. We are checking.
There will be questions there. You can solve those questions. Meanwhile, you can solve this one. What is the answer for this one? Yes, bacha, what is the answer?
B, sir.
B.
D, sir. No, D, sir.
D for Delhi.
Yes, sir. D for Delhi.
D for Delhi is correct. Okay. Now I'll again give you one more question, and this question is more like a note. So you can take it as a note. This is one of the most favorite questions that they ask. So you can solve it as a question and remember the result. Because the result is what it is, what is important. Question goes like this. A ball of mass, I hope you can see the question. A ball of mass m hits the floor, making with a velocity v naught, making an angle of incidence. Angle of incidence, the angle with the normal, alpha with the normal. The coefficient of restitution is E. Find the speed of the reflected ball and the angle of reflection. So at what angle it rebounds. You can also draw these two diagrams and you can just remember the result of this. You don't have to actually solve it. I'll just give you the result. Keep the diagram in your head, how it is falling and how it is rebounding back. Just keep these diagrams in your mind. I hope you will be able to understand what is there in this diagram. You are able to understand what is there in this diagram? It is
Yes.
falling with a velocity v naught at an angle alpha. V naught cos alpha, v naught sin alpha. The line of impact is the common normal. Do we understand this? So
Yes, sir.
momentum only changes along the common normal. Do we understand this?
Yes, sir.
After impact, it moves with a velocity v dash at an angle beta. Remember, along the common tangent, the velocity remains same. Do we see this? Velocity remaining same here. The only velocity that has changed is vertical velocity was v naught cos alpha downwards before collision. After collision, it becomes E times v naught cos alpha. So if you can remember these things, I'll give you 2 minutes to note them down.
Okay, sir. Time. Kaushik, time enta?
Noted down, bacha?
Yes, sir.
So what we need to remember here, so note down this as important points. What we need to note down here. Point number 1, V naught, the x component will be same as V dash, the x component. Do we understand this?
Yes, sir.
And that is equal to V naught sin alpha here. We understand this?
Yes, sir.
V naught का y component is minus V naught cos alpha. Why it is minus V naught cos alpha? Because it is going down. Yes or no?
Down. Yes, sir.
V dash का y component will becomes E times V naught cos alpha with a positive sign because it is upwards. This is downwards and this is upwards. Do we understand this?
Yes, sir.
V dash का magnitude can be written as under root of V naught sin alpha का square plus E times V naught cos alpha का square. Do we understand this? And the root of this. Yes or no? Can also find the value of this angle tan beta with the vertical. So you divide the horizontal component by the vertical component. You will get the answer. It will come as tan of alpha, the falling angle, divided by E, coefficient of restitution. Do we understand this?
Yes, sir.
One more note, if E is 1, that means it is a perfectly elastic collision, then V naught ka value will come same as V dash, and tan of beta, oh, I should not write tan of beta, then beta, the angle of incidence will become equal to the angle of,
Answer. Yes, sir.
that only happens if it is a
Elastic collision.
perfectly
equal to 1.
elastic collision between a wall and a ball. Do we understand this?
Yes, sir.
Let me see if you can do this question. We have noted this down.
Done, sir.
Let's see. The last question in this category. If you can do this, that means everything is good. Did you check that sheet? Questions are there in that sheet?
1 minute.
Would be there, right? Okay, this one. Question number whatever, we have done a lot of questions today. A smooth sphere of mass m is moving on a horizontal plane with a velocity 3I plus j. When it collides with a vertical wall, which is parallel to j axis, vertical, there's a vertical wall j axis. If the coefficient of restitution between the sphere and the ball is half, find these three things, and you have 1 minute to do this. Just bacha, able to do this?
Yes, sir. 1 minute, sir.
Well done. If you can do this, I'll be pretty happy. Let me check your sheet up till then. You will send you a sheet. Okay, so it seems that you are still trying. What will I do? I'll give you this question as homework. Try it at home, and I'll send you one more sheet on this collision, because I think that the sheet that I sent you was more on work by energy rather than on collision. So I'll send you one more sheet today.
Okay, sir.
Try the question from that sheet today only, because today only you can do this.
Sure, sir.
Tomorrow onwards, we are going to start with the next topic, and the next topic is
Rotations.
welcome to rotation. So we'll be starting rotation from the next class. Take care. Have a nice day. God bless you all.
Thank you, sir. Have a nice day.